For our next example, we have two plates shown in the figure that are joined together by a 425 millimeter rivets. The allowable shearing stress for the rivets is 70 megapascals, and the allowable tensile on net area is 100 megapascals, while the allowable bearing stress is 140 megapascal. So the question for us is to find or determine the safest load P that can be loaded in the system in kilonewton. Okay, so as you can see, meron lamang tayong three na consideration for shearing, for tensile, and for bearing. Because we cannot determine the tensile on gross area because it is specified that this is the allowable tensile on net area. Okay, so also for block shear, because we are not given with the three tiering and shearing value for our allowable tensile stress for tiering and shearing. Okay, now let us consider shearing in our bolts or rivets. So our shearing on bolts or rivets has a allowable shearing stress of 70 megapascals. So again, for shearing, our considered P for shearing is your allowable shearing stress multiplied to the area of shear. And this is just a single shear because we only have two plates na place natin together. So our P will be your 70 megapascal is the allowable, 70 Newton per square millimeter for megapascals. And our area of bolts and rivets, we have area of one bolt is pi over 4 multiplied to the diameter of the bolts, which is 25 millimeter squared. And we have one, two, three, four rivets. And our allowable P the value of the allowable P is in kilonewton, that is 137.445 kilonewton. Okay, next is for, I think we consider for net area. Okay, so as you can see, we have four bolts here. Okay, um, we can have your net area here. That is, let us identify your bolts as A, B, and C, and D. Okay, you can have your net area there, your net area here, and also your net area here. Okay, but on our role in mechanics, engineering mechanics, no, kapag ka nag-resist tayo ng force dito, ayan, di ba? Lahat to meron itong mga resisting forces against our load P. Okay. Together, yung system natin, we can say that our system resists forces, no? Nagre-resist siya ng forces of P over 4. Lahat yan. Para equally yung distribution. We assume that equally distributed or lahat sila equally nagpa-participate or nagpa-contribute sa system natin to resist this force P. Okay. If our net area, consider net area at A. Okay. If our net area of A, our area would be, the width of course, we will consider 2. Meron tayo kasing dalawang plate no, na pwedeng mag, mag, mag-tear due to tensile. And meron sila magkaibang width at magkaibang thickness. The difference between the two, this one has a narrower width pero mas makapal yung thickness niya. Ito naman, mas wide yung kanyang width pero mas manipes yung kanyang thickness. So we will solve for the both of that. Okay. So for yung ating plate 1 and plate 2. Okay, net area at A at plate 1. So we have a width of 130 millimeter and we have 1 bolts there which is 25 in diameter. So we have to plus 2 and we will multiply that to the thickness of 14. So the value of your net area at A at plate 1 would be 1,442 square millimeter. And that will give us a force P. So it would be multiplied to our allowable stress of 100 megapascals times 1,442. And it would give us, in kilonewton, we will have 144.2 kilonewton. So, how about yung ating plate 2? So, that would be 150. We have 1 bolt, which is in 27, the diameter of our bolt, because that is 25 plus 2 already, times the thickness of 10. So, we have 1,230 square millimeter. And so that our P will be 100 megapascal or Newton per square millimeter times 1,230 square millimeter, it would give us to an force P of 123 kilonewton. How about we take the net area at B and C. So let us change the color of our pen. Okay, if we take this path on this one, okay, if we take this path, okay, itong P over 4 na to, magiging another force na siya against our P. So therefore, pagdating dito, kung dito may nag-resist na si A ng P over 4, ang remaining force na lang na dapat i-resist ng ating B and C until to D o ng part na to starting here, ayan, starting here, ang i-resist na lang natin na force is P over or 3/4 ng our P. Kasi nabawasan na tayo ng P over 4. Na-resist na siya ng A. So, ang i-resist na lang natin ng system na naiiwan sa atin is that yung P over 4, P minus P over 4 or 3/4 of our P. So, yung ating magiging formula would be 3/4 ng ating P equals ating allowable shear and the net area. Okay, so for us to determine the value of P, supposed value of P. So yung AN natin, at the first plate, we have 130. Then we have 2 bolts with or rivet with a diameter of 27 and a thickness of 14. That would give us a value of a net area of 1064 square millimeter. And for 3/4 of P equal to 100 is the allowable tensile stress multiplied to 1064 square millimeter. Okay, now the value of our P here would be 141.867 kilonewton. Okay, so how about our net area, second net area? So we have the width of 150. We have 2 bolts B and C with a diameter of 27 millimeter, and the thickness of the second plate is 10 millimeter. So it would give us a value of our net area 960 square millimeter. Now we have 3/4 of P, and our allowable tensile stress is 100 megapascals times 960 square millimeter. So the value of our P is 128 megapascals. Okay, we also can consider the value of or the allowable tensile on net area at point or bolt D. And bolt D, so we have net area at D. At D, yung ating P, so na-resist na siya ng tatlo na may 1/4 of P na capacity. So ang ating resulting P na lang is P/4. Para in equilibrium yung body natin, di ba? Para pagdating natin sa D, dapat yung nire-resist niya is P/4 para in equilibrium sila. Kasi kung P pa rin ito, they will no longer be in equilibrium. Dapat equilibrium palagi. Okay, so net area natin. First, we have another 130 minus 1 volt kasi D na lang to times 14. And that is 1,442 square millimeter. And having the force of P/4 times 100 megapascals times 1,442, this would give to P equal to 576.8 kilonewton. Okay, how about the second plate? So we have 150, 1 rivet times 10. And this is 1,230 from according to the previous computation then with 1 volt. And it will give us P/4. You have allowable tensile stress of 100 megapascals times the area of 1,230 megapascals. So our P is 492 kilonewton. Okay, so another thing to consider is our bearing on plate. Oh, okay, as you can see, we have, since for bearing, so for bearing, our area for bearing is your diameter, number of bolts times the diameter of the rivet multiplied to your thickness. Okay, you have two plates here. The other one has a thickness of 14 millimeter and the other one has 10 millimeter thickness. So if we are to choose, we can also solve for the both of them. But of course, the one with a thinner thickness or a smaller thickness would give us the most critical P. Of course, mas malaki yung value na makukuha natin from 14 millimeter. So, what we are looking at is the smallest value of P kasi iyon yung safest. So, we will use 10 millimeter. Okay. So, for area of bearing, we have 4 bolts or rivets with a diameter of 20 with a diameter of 25. Okay. With a diameter of 25 and a thickness of 10. And it would give us an area of 1,000. And the allowable bearing stress is 140 megapascals. So the force is allowable bearing stress multiplied to the area of bearing. So 140 megapascals multiplied to 1,000 square millimeter, it would give us a P of 140 kilonewton. Okay, so the same process in looking for the value of the safest value of P, we will look for the least value of P. So we have this one, 123 kilonewton. So this is the safest value of P. Okay, so that's it. Okay, I think you may try to some other problems.